hand it to Sébastien.
So this was a project that's started a while back, actually. So I'm somewhat oldish, but still, I think it would be nice to have this implemented, the CFHT. You'll see why. This is fairly a cheap way to improve our IQ and possibly the sky. And this will be also a good introduction for the next talks about more or less improving IQs as well. So why are we doing this? We all want better efficient telescopes. Just like JJ, I did a few ChatGPT things. It didn't go so well for me. The real lights don't really go well. Anyway, the idea here is how could we improve the IQ without really modifying anything that we currently have. A little bit of modification, but not extremely difficult ones. And then also, so it would be the IQ, and then maybe increase signal to noise by maybe doing better scheduling to see where we could predict the sky background, basically. So if you take the distribution of IQ and you measure it on every single single image taken at MegaCam, this one ended at 2020 or 2021, I think, if I remember. And then you compare, this is the pink one, and then you compare this to what you actually measure in the MCAM tower, which is a little tower that measures atmospheric seeing and the dim one at next door, basically. And then you can see that there is a little bit of room that we could go to from MegaCam to here. That's where we're hoping to get here a little better here. Obviously, for the free atmosphere one, it will be a lot more difficult. So there was, we were not the first one to do this. Maybe doing more like a data-driven one. Maybe we were at this scale, maybe the first ones, but there were a bunch of things that were done in the past, in particular from Derek, from René Racine, and back in the days. About trying to see which part of the IQ is actually we could modify to we could actually influence. So what we took a bunch of sources, data, so telemetry coming from the whatever we have available, basically, the sensors inside the dome, outside the domes, wind speed, direction, humidity, dew points, pressure, external seeing measurements from the MCAM tower. Then we took after also we go back to 2003, but in 2014 there was these vents that were installed, and you'll see that it happens to have you probably already know that they have quite an effect on IQ. And then so we have all these vent configurations, and other things more related to the telescope, and then the things related to the actual exposures we measure, because what we want to do is basically measure the IQ on what the scientist wants to have, the proper IQ measure, all the way back to the different telemetry data. And if you take a time series of the measured IQ from 2005 to 2020 and so much, then you can see here the installation of these domes. The dome vents definitely help quite a bit in the median IQ. So what we did is what else? Lots of things else, but in this case, we don't have really a physical model to do all this, match all this data together and actually predict how we could have the IQ. So we made a gigantic effort of data collections. A lot of people at CFHT were involved, and me at CFHT, at CADC, sorry, with the CFHT data. And then we did a lot of feature engineering to make sure that everything was proper for the network. This was actually probably 80% of the job with all these things. And then we made a neural network to make what we call a probabilistic neural network to get the probability of what the IQ would be given the sensor data we actually measure. And no, we never get rich. It's not a Kaggle competition, unfortunately, but maybe one day. Yeah. So what happens? So you can measure this just as a predictive, not a forecasting aspect. So here, this is the measure IQ with all these uncertainties. The measure IQ, and then this is the predictive one that we actually measure. We were fairly careful with all the uncertainties as well. And basically, what you have to retain from these things that we get the IQ predicted at 0.07 arc-second. And these are the uncertainties also in function of the IQ, and then you can see that the higher the IQ is, the more uncertain we are actually predicting. Then you can do this effort of, so what are the main contributors of these IQ? And then from all the sensors that we have, so we can do this attributions, methodologies that now is becoming a little more common in machine learning. It's not 100% sure that it will be actually correct, but it's a give a good guide of what what it is actually. And then what we found out is this is the reg of all these different attributions. The temperature was quite important. Just the time of the year, obviously the wavelengths, although we already divided everything, we already removed here the wavelength part of the IQ. Pressure, I mean, a bunch of little things that could be, that could influence the prediction of the IQ there. And then we thought, okay, so how we could actually improve this IQ? Then we modified the vents a little bit, and then was the nominal vent configuration. We modified them a little bit, and then we by artificially, and then measure the IQ with our prediction model, and realized that we could do a little better by just having a little more optimal configuration of the vents open or closed like that. And then we realized that this was not exactly the correct way, because in our training set, there was not so many vents which were randomly open. So we were what we call out of distribution. So we made the full analysis of proper uncertainties and in distribution, vent configuration, etc., to actually obtain more or less the same plot, but with a lot less data. So at the end, what you have to retain from that is yes, we can do a little better, about 0.1 or 2 arc-seconds, and then it gets better, the worse the IQ is there. Finally, we did also the same process just recently, not so recently anymore, but with the sky background. And so we collected a bunch of sources. Here the solar radio flux, which is taken at Penticton, a bunch of time series from the 0 points with the Sky Probe, the JSMT water vapor monitor, and also the similar ones that we had for the IQ predictions. But here, we don't really can't control much, so really more the idea is to forecast what the sky prediction would be at a given time of the night. So this is a little bit of work in progress. We're still going through this. We changed the model a little bit here. We switched to a gradient boosting tree. We did a little bit different uncertainty quantification, but more or less is the same idea, really. And then here, this is what you can see on the measure sky background versus this predicted sky background. We do pretty good here. This is forecasting. So, and then we mix actually WordCam as well. And then if you do it, just an example, if we ever go for like a full U-band survey, for instance, then this is a little bit more noisy, but we stopped in 2020 here, 2021, I think, and then there's still processing ongoing now. And then if you do it predicting but not forecasting, and then it's a lot better. Predicting means it's like a now casting that you will actually predict at the time. You cannot go ahead of time. It's a much different process to feature engineer the data. This is the residuals of prediction in relative residuals in time. So you can see here we are about below 10% in average in predicting in the nowcasting part. This is the U band, similar, more noisy because we are less training data. Here we have the full set of contributions as well to what actually affect the sky predictions, the forecasting. And I'm just going to leave my conclusion. Basically, a cheap way to actually improve our IQ, possibly the sky, by scheduling. And there's a little bit more work in progress to finish up and close up this work now. Thank you.
So I think we have time for one quick question. David?
Add the predictive power you schedule and we're actually taking the Islamic class only for actually dynamic information.
Yeah, so there's these two parts. We want to see which one actually affect more the seeing. So in this case, we can actually within the dome, like these bands. Could we actually do this with the IQ? But also we can prepare the scheduling of the night. Yes, exactly. I don't know.
Well, memory. And second to that, you close sharp writing the dots. You're now under good, now over good. And I get off a little efficiency those surf minutes. Really game changer. Whereas light as into that state is really.
But you mean you have a prediction model then?
No, medical.
Because you do fast enough to actually schedule everything at the yeah, okay.
Yeah, I remember. Don't make it but that's really the condition.
Yeah.
Well, great. But still get that.
I guess it would be a question for what a CFHT people than me.
Well, maybe we should defer that to the discussion afterwards. And we'll thank our speaker one more time.